Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at how to solve the question on electrochemical cells that's on the board. And the question is as follows. Consider the cell here. The electropotentials are, for zinc ions, it is minus 0.63 volts. For copper, it is 0.350 volts. And we are told to first of all write down the cell reaction and to calculate the EMF of the cell. Now, if we look at these two equations that are here, they are showing reduction of zinc ions and reduction of copper ions, which tells us one thing, that the two values of electropotentials we have here are reduction potentials. But when you look at the cell, you can see that zinc atom is losing electrons to give zinc ions, and copper ions is accepting electrons to give copper. So this half cell here is the anode, and this other half cell here is the cathode, and the anode is where oxidation occurs. So it means that to be able to write down the cell reaction, we have to write the equation at the anode, which is that zinc atom loses electrons to give zinc ions, and then at the cathode, copper ions accept electrons to give copper. So what you have here is the reaction at the anode, and then what you have here is the reaction at the cathode. So to get the overall cell reaction, cancel out the electrons, you write what is on the left hand side together and what is on the right hand side together. So this will be zinc plus Cu2 plus to give Zn2 plus Cu. So this is the overall cell reaction. This answers the first question. Now, for the second one, we are told to find the EMF of the cell. Now, for us to find the EMF of the cell, let us not forget that at the anode, that's where oxidation takes place. At the cathode, reduction takes place. But like I said, these two values that we're given here are reduction potentials. These two values here are reduction potentials. So, if I want to get the oxidation potential of the anode, I would simply change the sign here. So, it means that the oxidation potential of Zn2 plus, which is the zinc half cell, is simply going to become 0.763 volts. So it's important to note at this point that if you are given the reduction potential of an electrode or for a half cell and you want to get the oxidation potential, just change the sign. So since the reduction potential is minus for zinc half cell, to get the oxidation potential, we'll simply change it from minus to plus. Now, the reduction potential for the copper half cell, the reduction potential of the copper half cell is already given to us here, which is 0.350 volts. Now, when I was teaching you how to calculate the EMF of the cell, I actually gave you three different formulae by which this can be done. Now, to get the EMF of the cell, we have the oxidation potential of the anode and the reduction potential of the cathode. So the EMF of the cell in this case is going to be the oxidation potential of the anode, plus the reduction potential of the cathode. So this is simply going to become 0.763 volts plus 0.350 volts. We add this, it is going to give us 1.113 volts. So it means that EMF is simply going to be 1.13 volts. So I want to believe that explanation to this question is clear. I also believe that you have taken note of the information I've just given, which is to change or to determine the oxidation potential when the reduction potential is given, or to determine the reduction potential when the oxidation potential is given, all you need to do is to change the sign. Thank you very much for watching, and see you in the next lesson.